The ionization of atoms and the trend in the periodic table. What is ionization? It's a verb, and it's actually really easy to figure out what it is if you just talk about the ASL. So the sign language for a nucleus is this. Taking your two fingers and just pressing them, that's the nucleus in ASL. Now, ASL for an electron is this. So you have a nucleus, and the electron goes around the nucleus. It's ASL for the nucleus and the electron. Now, ionization. Watch what I do. Watch it again. So you can see what ionization is. It is removing an electron from an atom. Now, to draw a little picture of that right here, let's say we have a nucleus of a couple protons, and I'm just going to quickly draw a helium because that's all I have time to draw. I'm not going to draw a bunch right here. Helium has 2 electrons and it's 1 s orbital. So the ionization of a helium atom is removing that electron completely from the atom. Not borrowing it, not temporary, not for a moment of time, a complete removal right there. This requires energy. This requires energy in the form of, in the unit of joules. And that energy could be transmitted through heat, mechanical, different types of energy, nuclear energy, all different types of energy there. All right? Now, the trend of ionization in the periodic table. Before we draw that out, consider the following. I'm going to draw another helium nucleus. And another helium atom. These helium atoms have the same, they have identical nuclei. Those are heliums, number of protons, number of neutrons. This electron is going to be the one that is ionized because it is the outermost electron, the valence electron. And this is what is creatively called the first ionization. Now, these are both depicting first ionizations. You know what an ionization is, and here is what it means to say the first ionization. It is the ionization of a valence or outermost electron. Now, the question I ask to you now is which of these electrons is going to take more energy to remove? The electron that is closer to the nucleus is going to be harder to remove and take more energy. This attraction between the nucleus and that electron is much stronger because it is closer and just more likely to coulombically or magnetically strong, S-T-R-O-N-G-E-R. So it's going to take more energy to remove that one there. Now, one way to phrase this is the electron that is closer to the nucleus will take more energy. A similar way to phrase that is the smaller atom will have a higher ionization energy. Smaller atoms, the electrons, the valence electrons are closer to the nucleus. You agree this is a smaller atom compared to this one. let's write out the trend of ionization on the periodic table. Now as I draw this out, please take note of the direction the arrows point and the adjectives I use, because if you watch other people's videos, they may just flip-flop it and it can be real confusing real quick. So I'm going to be very careful how I do this right here, okay? Now, as you move to the right on the periodic table, you have a larger ionization energy. It takes more and more energy to remove that first or valence electron. So if we were comparing, say, elements, magnesium right here, and say phosphorus, aluminum, silicon, phosphorus right here, phosphorus would have a larger ionization energy, a larger first ionization energy. We move up the periodic table. Things have a larger ionization energy. So if we compare, sticking with, say, this column right here, if we have phosphorus, nitrogen's right above it. So if we were comparing these two, we would say nitrogen has a larger ionization energy. It would take more energy to remove the valence electron from nitrogen. Thank you.